So, you know what? I should share, stop sharing. Let's go. Let me share the second screen first. Okay. So here, let me use the whiteboard to show you what are the functions we need to create. Okay. First, I need to create a function to map integers into characters. So basically, we are creating a function to kind of like use ASCII, ASCII, American Standard Code for Information Interchange table. Okay, so that table basically is kind of function that will convert integer. So for example, integer whatever code, okay, let's say integer code, and then into characters, into char, right? So basically any numbers from between 0 to 127 will be mapped into one of the letters, like A, B, C, D, or sometimes like a tab or space. So all of that will be based on the ASCII table. But what if you have integer which is not in this range? I said you have to either subtract 128 using while loop, or add 128 using smaller than 0, so that the number will be in this range. Okay, and then after that we can convert that to character. So the function head will be char. So let's give a name for this. Okay, so let's say to char. To char. Okay, so char, and then to char, and the parameter in this case will be just integer, some kind of a code. So any integer. Okay, and then you're going to write a code in between like that. So this is the function we are going to use for our encryption case. So encryption, let's just say you have a function name called encrypt that will encrypt a message. Message is string, right? To any unrecognized message. So that would be encrypted. Encrypted message. Okay, so that is also a string. So when you do encryption, you need a key. Okay. Generally, the key can be anything. Can be like a text or can be integer. So in this case, we are going to just consider integer key. Key is kind of integer. All right. And then, of course, there are many ways to do encryption. I guess not a common approach. I think probably basic approach, almost the simplest approach that we can code easily is called Caesar's cipher. The basic idea is that for each character inside the message, you convert that into some kind of number, integer first, and then you add that integer to this key, so you get a new integer, and then you convert that integer back to a character. Okay, so essentially, if you're given, if you look at the ASCII table, you basically say for each character you parallel shift to, for example, to the left or right, to the right. For example, if you say 3, you shift 3 positions. So, for example, A will be shifted to like a D, 3 positions, and the D will be shifted to E, F, G, and then something like that, right? So let me just explain the idea. So just imagine, okay, suppose I have letter A. Just say that letter A corresponding to integer 101, okay? And then suppose the key is equals to 10, okay? And then what you would do is for this letter A, you will just simply use the 101 plus 10, and then you get a 121, right? And from 121, you use ASCII table to find out whatever character. Let's just say that character is D. Okay, I'm not sure this is correct, okay? But just give you an idea how this will be done. So then the A will be mapped to D, it will be encrypted to D, and then some other letters will be doing similarly. Okay, so then eventually you get some kind of message that will be not recognizable unless you know what is the key. Okay, so that is the function we are going to write next. So the function head will, in this case, will be string. That's output type. That's basically this one. Let me show you this. This one will come here, okay? And then the function name is encrypt. Encrypt, okay? And then there are two parameters. One is original message. And the second parameter is key, initial key. And then you write the functions inside. Okay? So basically for this character, you're going to convert into char array of characters. And then for each character, you're going to convert into integers. And then you add the key, and then you call the function above, trying to map that integer into code. And then you gradually add that letter back to the result, to the encrypted message. And that's what we're going to do in the first example. Does it make sense? Okay, so I'm going to just start that. So let's just go to stop sharing, go to first screen. So I'm going to move this away. And I can also move this away. All right, so now let's open up the Visual Studio project that we were working on Monday. So let me see, where is that? 3:15. Okay. Let's see what I think we did the sixth example, right? So we'll continue that sixth example. Okay, so let's do the first function, which is ASCII table conversion. So in that case, the result is going to be char. And I say to char. Okay, and then here inside is some kind of integer, which is the code. All right. So when the code is bigger than when the code is bigger than 128, then we have to subtract that. So while code is bigger than 128, then we just keep on subtracting that until it is smaller than 128. So we'll do code equals to code minus 128, semicolon, right? So this is the case that if the code is bigger than 128. On the other hand, if a code is less than 0, then we are going to add 128 continuously. Code equals to code plus 128. We did that code before, okay? Now we just need to, we put things inside a function. we learned how to use a while. We did this example in while. We learned in while loop. I think that was a week. Was last Monday, I believe. Okay. And now after we have the character, which is between 0 to 127, between 0 and 127, this one bigger than 127, sorry, bigger than 127. So if the code is between 0 and 127, then we are ready to use ASCII table to do conversion. So let's say character, let's say result C will be equal to, and then we just need to convert that, implicitly convert the integer code into character, and then we return C. There we go. So then this function will give you a character corresponding to any integers that you may have. Okay. Does it make sense? Does anybody have questions? Yes or no? Now, if there's no questions, now let's do the second function, which is encryption. And we are ready to put this function into use. So string, and then let's say encrypt. Okay. Then it has original message. Let me move this up. Original message is MSG. Okay. And original key, the key value is key. So apparently, first thing we need to do is we need to convert this into array of chars. So we use char to char array. So let's create array first. Okay, array, and then say chars. Okay, this is chars in message in MSG. Okay, equals to MSG.to char array. Simple as that. And now we have an array of characters. So now we just need to make each character, handle each character, make each, so get each character and then convert that into integer and then add the key. And then we convert it back to character, okay, using the function above, okay. So then eventually after we get the character, we add it to the result. So we create the result variable first. Just say result. So essentially, initially it's just empty string, nothing else. Okay. All right. And then we can use for loop for integer I equal to 0. For loop to process the array, and I less than the chars in message. Okay, that is char array, right? The array of characters, and then dot length, so less than the length, so that will be the last character. Length -1 is last character, or semicolon, and then I plus plus. Okay, so this is I equal to 0, sorry, I equal to 0, and then this first step. The last step will be I equals to chars in message dot length -1, and then we have I plus plus. This is I plus plus. Okay, so increment. Okay, so now we are ready to process each character. So the first thing we want to do is for each character, I will change to integer first, and that is actually done by casting. So we'll say integer. Integer some kind of let's just say integer code. Okay, code is equal to integer, and then chars in message square bracket I. So let me explain what happened. What is in this? So there's I's character in the message. You just change that to like you use this explicit cast to change it to character. So that's basically just opposite to you're still using ASCII table, okay? And so that basically just make that as integer. And now we just need to make a code equals to code plus key. So we add the key value to the integer. All right. And then after we have the integer, we can now call this function to generate or not to create a character. So now let's see what do we need to do. Okay, so to call this function, first of all, we need integer. Do we have integer code? Yes, we do have that. Okay, then we need a declare variable to hold output. Do we have that? We don't. So we need to create one like that. So what we do is, you know what? It's not a good idea to declare variables inside the loop. It might be better just declare this loop outside. Okay, so I will do this outside. Okay, so I'm going to declare variable integer code. Okay, and also char, let's say C. Okay, char C. So then we do not need this declaration anymore here. Okay, so we declare the variable before the loop, so that way we don't have to use a loop, keep declaring new variables. Okay, so what does this do is first you declare the code, which is for a customer kind integer that represent whatever integer representing each character in the message. Okay, and then use that code plus the key value. All right, and now we are going to use this as output. So C is equal to, and let's call the function to char and then code. Okay, so this basically is just use this integer and as input to this function, and then this function will return a character which is whatever C. Okay, whatever character. And after we have the character, now we just need to add the character back to to the message, to the result. Okay, so we'll say result is equal to. So here, just make sure we add in the right order. So first place should go to first place, second place should go to second place. So we should follow the original text. Okay, so we should do add result to the right. Okay, so after we have the first three, then we add a fourth. After we have fourth, and then we add a fifth, so we add them to the right, right? And we will do the C, and then we have to do say to string, because character is not a string. It's not a string, so you have to add that. So then this will process all your characters inside the message, and then convert, use whatever the key add to the key to the integer number representing each character, and then you convert back to the character and add a character to the result message. And then finally, after this is finished, and then just simply return the result. Okay, there we go. All right, so now let's try to use this function, call this function in using the user interface. So let's just say I'll create two message boxes. Okay, one for original message, one for encrypted message, and then we create a button to call this encryption. So let's try to say what's going to happen. Okay, so let's go to forms one, and then we have txt box. Let's just create another text box, because we may need to type a long message, right? So let's just type, say this is wrong. Go to toolbox. So first, let's create text box for message. Okay, so let's make it bigger. And we can also make it a multi-lined, so that way we can type whole paragraph or whole article inside, right? Okay, suppose this is your email message. Okay, so let's just change that name to txt original. Okay. And then we're going to create another text box for encrypted text. Text box. Okay, let's put it here. Also make it bigger and also multi-lined. Oh, let's see, multi-lined. Right here. Okay. Okay. And then let's see. So this will be just encrypted. So txt encrypt, txt encrypt, encrypted. Okay. And now we can put a button to do the conversion, to call the function we just created. Okay. So for this button, let's just say, let's give a name. Let's just say this is ETI encrypt. Okay. And for the text, we can just say that's encrypt, or it's simple, we can just do this. Okay. You just see this direction, encrypt. Oh, by the way, we need a key. We need a key. So for the key, I'm going to use one of the text box here. So let me move this text box to here. Okay. Suppose this is the key. I think this is called txt-c, right? Yeah. So just, if you want to make it formal, then you probably put a label here, say this is key value key. Okay. So, all right. So we have original message, and then we have a key, and now we press this button. I want this, function to be called, so to generate the encrypted message. All right. Is that clear, everyone? Now let's double click, and then let's see how do we call the function. All right. The first thing we want to do is for each of input, we need to have variable initialized. So we need to create a message, create a string input. So that maybe just say we can call it message, and that will come in from txt original dot text. Okay. So declare and initialize, and then we also need a key, integer key, that will be coming from txt-c dot text. But then we need to do conversion. So we need to convert to integer to integer 32. Okay. All right, so we have inputs, and now let's say we need output. So we need to declare variable for output. So that will be just simply a string. So let's say that is encrypted message. Okay, so that's output. After that, we are ready to call the function. So we'll say encrypted message is equal to encrypt. No, not this one. Encrypt the function. Encrypt. Yeah. And then we need to put two inputs. One is message, which is MSG. And then the second one is the key. It is your key value. There we go. So now we have output, which is encrypted message. So we are ready to display the message. txt encrypted text equals to encrypted message. So it is as simple as that, because we already have function which already encoded complexity of encryption. But then calling the function becomes so easy, right? All right, well, let's have you finish it. Now, since we are doing online classes, there's not much interactivity. I do want you to tell me if you are behind, okay? Otherwise, I will assume that you are typing as normal. You are on track. Everyone's okay? Okay, now let's run it. So what is this? Okay, that was from the original one. So let's just get some kind of a text here. Let's just say, I love you, Mary. Okay, something like that. And then let's just say integer key is 123. Okay, so can be any key. Now let's press this button, and then you can see that the message is not recognizable, right? Can you recognize that? So this is the power of encryption. Okay. So if you, for example, your two parties agree with a key, then if you pass a message like this, and then even though some other people may intercept your message on the internet, but he or she will not be able to tell what is this message, right? Okay. So this is what encryption is doing. Now let's try to do call the function, same function again, do decryption. Okay. So in other words, we actually, if we have this message, I can get it back, recover the original message. Okay. So we do not need to create a new function called the decrypt. We can just use the same function to do it. All right. Let me close that. Okay. So what I need to do is just create another button to decrypt. Okay, so now let's see the mess. Let's give the button name btn decrypt. And for the text, I can do something similar, just use something like that. Okay, left arrow. Okay, so now let's trying to do decryption. So when we do decryption, then the input is going to be from the original, from the encrypted message, and then you want to call the same function again, and to recover the original message. So what we needed to do is that we will use the same key, but we change that to -1. So let's see. Okay, so first of all, input for the function. So that would be encrypted message, right? Okay, and that will be coming from txt encrypted message dot text. And then what about the key? The key is going to be integer. Key will be we will use the same key value, but then we just need to change it to negative. So negative, and then convert to integer 42 txt text. Okay. So you understand that the message, or encrypted message, was adding the key value, right? So now we just need to subtract that. So that's why we make key equals to the negative. And now we need to get output. Output will be original message. Okay. So now let's call the function original message equals to the function, the name of the function is encrypt. Okay, so we'll do encrypt. Okay. And then what we need to do is, in this case, encrypt the message will be input, and then the new key value, which is actually a -1, will be coming from this variable already initialized. And then let's just get display the original message using txt original text. Okay, equals to original message. original, that's too much. Original message, like that, okay? So assuming that you already have a decrypted message, and then use this one, this button to recover the original message. Let's do it, okay? So what am I going to do is, let's see the start. One. Okay, so first I am going to just copy something from somewhere, put into here. That's the first, that's the message, right? And then let's just use a key. So let's just say that key is like whatever, 98, all right? So whatever value. And then let's say what you generate the message. So the generated message is not recognizable anyway, right? Okay. So let me get rid of the original message. And this is suppose the message you received, encrypted. And if you know the key, okay, just enter that, say 98, right? And now you decrypt. So there we go. So you get the original message back. Isn't that pretty magical? So if you take like, I don't know which class, it's called 520 slash. That class is about network security. They should cover concept of encryption or information security. Okay. So anyway, that this is basically illustrated the concept of encryption. Get that good idea? So the original message, even though I deleted it, now I get all of them back pretty quick, right? All right. So now let me see whether you have any questions. Let me pause for a few seconds.
I had a quick question.
Yeah.
For some reason in the code where it says encrypted message equals encrypt parentheses message comma key, for some reason in both my equations, encrypt is underlined and it says it does not exist.
Does not exist. So do you have a function called encrypt in there?
Oh, let me check.
That was the name of the function we created.
I do have that, but for some reason it says the local function descript is declared but never used.
Okay, so that is case sensitive or something.
Okay, I must have misspelled it or something. I could always check with you later.
Yeah.
Thanks.
Okay. So if you compile, should make sure that there's no error. If you have errors, just comment those sections out. You know how to do that, right? So if you say build a solution, you should have no errors because otherwise you're going to have a problem with future code. All right, any other questions? If there's no other questions, now let's try. Remember, we were trying to do last week, actually, last Wednesday, we're trying to do binary conversions. Say if I give you like a decimal number, how do you convert into binaries? And also I introduced the idea that how can you convert that into like a octal number that is 8-based or hexadecimal number that's 16-based numbers. Okay, so let's try to do that. First of all, let's do binary numbers. And the code was already already developed before we do. I think we do while loop also. That was last Monday or week before maybe. So we're trying to divide by 2 continuously until the number is no longer more than 2. And then each time when we do division, we just put the remainder and the remainder to the result, right? To the result stream. Okay. So in that case, so remember the input is going to be integer. So let's just let's say the function head should look like what. So first, output is going to be string. Okay. So I'm going to just use a string instead of binary numbers because we're trying to do like a octal number and also a hexadecimal number. Hexadecimal number use letters like A, B, C, D's instead of 1, 2, 3s. Okay, so let's just try to make it general. All right, so let's say that it will be say 2 binary as a name, and then the integer input is integer, some kind of integer, say n. Okay, so that is a function that we're trying to write a code for. So we are given integer. That integer could be 23, could be 148, whatever. Okay, and then I want to convert that into binaries, right? So first of all, I need to declare a result which is a string. Okay, and make it empty. And then every time we do division, we have to use a remainder, right? So we'll do integer remainder. Okay. So that remainder is going to be 0 or 1. Either one, all right? Okay. And then we use n divided by 2 and get a use a remainder. And then we get a quotient. So let's also declare a variable called a quotient. Maybe not necessary, but let's just try to make a code similar to what we did before. Okay. So now, and then the first thing we want to do is so first I will initialize the quotient to the n equals to n. Okay. You initialize the quotient to this, so there's no division done yet. Okay. So now let's start with division. So while while quotient is bigger than or equal to 2, then we'll do division. Okay. So if that's the case, then we divide and then we get a remainder. So remainder first is equal to the quotient, and then percentage sign 2. So that's modulo 2, right? And then we add that remainder to the result. So remember, we are going to do, how do we do that? So the first remainder will be coming to the left, right? Is that right? So let's say we do. Let me try to refresh that again. Suppose I have. So let me go to switch this screen. Switch to second screen so that you can see what I'm talking about. Okay. So remember, if we do, suppose I do 23, right? 23 divided by 2, your quotient is 11, and this is 22, and the remainder is 1, and the remainder 1 will be coming as the right, yeah, the first binary digit. Okay, and then we do 11 divided by 2, and the quotient is a 5. Then this is 10. Remainder is 1. So this remainder will be coming as second bit. Okay, and then we continue. Do you still remember that? So this remainder 4. Remainder is 1 again. So this one will come in as that. Okay, so that basically we are going to add the number to the left. Every time we add a new number, the number will be added to the left. Okay, so that we go back to the other screen. Okay, so this remainder we just added should be added to the left of existing result. So result is equal to the remainder plus result. Look at that. Is the remainder misspelled? This should be same thing as this one. R-E-M-A-I-D-E-R. Oh, I'm remainder. I misspelled. Remainder. Okay. Usually you should have this converted into characters, into strings first, and then add the result. But in this case, because we already have a string and a plus integer, and then this integer will be implicitly converted to string, right? You remember that, right? So we do not need to use conversion, use convert to string anymore. And then we change the quotient. So after we do division, then we do quotient. It will be equal to divided by 2. So new quotient will be divided by 2. Okay. And then this process will go back to the while loop and check again, see whether it's still bigger than 2. If it's still bigger than 2, then you get a new remainder, and then you add the new remainder to the result, and then this this will and then divided by 2 again. Okay. And so this while loop will be able to get all those remainders one by one. And then finally, if the quotient is no longer bigger or equal to 2, so then the quotient should be 0, 1, right? And then we just need to add that to the result again. The final one, result equals to quotient plus result. So the final one. So after we finish the loop, the quotient should be either 0 or 1. So that if you do another division, that should be remainder. So we just simply add that to the result. Okay, and return result. Here we go. Make sense? Okay, so let's you know what? Before we call this function, let's do, say I want to do create like a convert to 8-base number, octal number. Okay, so we'll follow the same process. So string to octal. Okay, and also using integer, which is 10-based. So when we talk about integer, we say integer is going to be all 10-based. Okay. And then, so given the integer, we divide by 8, and then use a remainder. So basically, same thing, same process. All right. So we pretty much can just copy the above the code. So that maybe you can consider that as like another exercise. So first, declare variable. Decide for result, and then we do remainder. Okay, so this time the remainder could be 0, could be 1, could be 2, 3, all the way to 7, right? So if you divide it by 8, so those are the possibilities, right? The remainder could be 0, 1, 2, 3, all the way to 7. Okay. All right, and also we can just say integer quotient. We also have quotient. Quotient will be equals to, let's start with n. Okay, and then we also use a while loop. While this quotient is bigger than or equal to 8, then we keep on dividing by 8. So you see the code is pretty similar to just the one above, right? So we're going to do quotient after the remainder first. So we find the remainder of the division. So that quotient, and then percentage sign, which is a modulo, and trying to find remainder 8. Find the remainder by dividing 8. And then we add the result, add that remainder to the result. So result will add to the left. Okay, so that will be remainder plus result. Okay, so then we actually have to divide the quotient. Quotient will be equals to quotient divided by 8. So we get a new quotient, and then we use the new quotient to check to see whether the new quotient is still bigger than 8. If it is, then we go through the loop again. And after this loop, the quotient should be less than 8, right? Should be between 0 and 8, between 0, 1, 2, 3 to 7. And then finally, we just need to add the number 2 add the number to the result. Okay, so result is equal to the left, right? So that will be quotient plus result. Okay, so then you return the result. Okay. All right, now let's try to call the function. We have we have plenty of time, so we should be able to. So let's try to call the function on the form, and we will use either one binary or octals. But let me just do we do both. Okay, we do both. So let's say let me see what do we do. So we are given integers. So let's just use these two text box A and text box B. Okay. So text box A will give you integer, and then text box B will show what is octal number or binary number. Okay. So I'm going to just create two buttons to do that. So let me move these buttons away. Okay. And then we're going to do buttons in here. Let's put a button inside here. Okay. So create a button here. Okay. So let's say there's a BTN binary. Okay. And then let's say give a name. I'm trying to get a downward arrow, but I guess I cannot do it on my keyboard. So I would just say to binary. Okay. All right, so this function, with the calling that function, it should be very simple because you just get the integer from here and then output the result into the second box. Okay, so let's try to do that. First, we are calling the function to binary. So you need to have input, which is integer, and you also need a variable for output. So integer input, so let's just say integer n equals to, coming from the first box, convert to integer 32, and then let's just say that is take as txt_a.text. Okay. Okay, and then we need to declare output. So output is going to be some kind of string. So let's say output. Okay. Or maybe binary data, binary value, binary number, bin value. Okay. Okay, now we can call the function bin value is equal to call the function to binary, and then integer is n. There we go. And then we can just output into text box B, because output this is binary. By value is actually some kind of a text, so we can just call the by value without any conversions. Okay. So, and now let's try to create another one to do octal numbers. So let's say you probably have not seen octal number unless you're a computer science student. So let's just create another button to do that also. Okay. Here. Okay, so BTN octal. Okay. And then just see this is octal. All right. And let's do it again. This time, this button will call the second function, which is to octal. To do that, you need to have input, which is integer, and output, which is text. So we need to declare two variables. So input n is coming from the first box again to integer 32 txt a dot text. Okay. And then output, which is octal value. So now let's call the function octal value is equal to 2 octal. No, not 2 bar. 2 octal. This one. And then you need to have an output input, which is n. Okay. So after you have the result, let's just show the result in text box b.text is equal to octal value. Okay, there we go. So we can try both buttons, see how binary numbers and octal numbers are obtained. Have you finished it? Yes or no?
Can you leave the screen up for just a moment?
Okay.
Thank you.
Ready? All right, so now let's test it, see how it works. So I put some kind of integer here, integer, right? Let's say the binaries. Okay, so binaries using 0, 1s, right? Okay, so that's just a binary number. Okay, now let's say for the same number, if I want to generate octal, and this is octal. Octal number is every bit, every digit is between 0 to 7. Okay, you cannot have a number more than 8. If you have numbers more than 8, then you just add 1 to the next digit, increase 1 to the higher digit, one higher digit. Okay, so this is octal number. All right, and we have about 20 minutes. Then in this 20 minutes, I want to do hexadecimal number. And the hexadecimal number, I'm trying to write that number. It's called hexadecimal number. Okay, so it's a 16-based. 16-based. So that means every bit, every digit, starting from 0, 1, 2, 3, all the way to 9. And then you're supposed to have 10, 11, 12, 13, 14, 15, like that. But you cannot have more than 15. But then you cannot, of course, in one place, you cannot write 10, because 10 has 2 places, right? Two numbers, 11 is 2 numbers. So what they do is they're trying to put a 10, map 10 into A, and 11 into B, and then 12 into C, and like that, C, and then D, and E, and F. So basically, you are using numbers from 0, 1, 2 to 9, and then plus A, B, C, D, and F. So in total, you have 15 numbers. Does it make sense? So that that's what 16-based number is going to do. So first of all, let's try to do the function to do the mapping. The mapping will basically from any numbers between 0 to 15, I will map to, if it's between 0 to 9, we just use the number, and then if it's number, but if it's not, I will just convert that into A, B, C, D, E, and F. Okay, so that function, let's just use a string as output, string, okay, and then the function is to map, okay, map for hexa, okay, for hex, okay. just trying to give a name. And then the integer n. So this integer is going to be between 0 to 15, okay? Between 0 to 15. So let's declare first for declare result, which is kind of string, equal to nothing. Well, we doesn't matter, does it? Yeah, we can just do nothing first. Okay. It's an empty string first. And then we are going to do if, so if n is between bigger or equal to 0, and n is less than or equal to 9, okay? Right. And then we will just simply say return. I don't need the result. Let's just say result is equal to just equal to n, but then we need to convert to string. Convert to string. So does it make sense? So basically, if the number you are trying to map is between 0 to 9, you just simply use 0 or 9, 0, 1, 2, 3. You do not need the map, okay? Now, else if n is equal to 10, then we say result is equal to 8. Is equal to 8, like that, okay? And then let's do it again. If result is 11, else if n is equal to 11, double equal 11, then we change to b. Result is equal to b. Okay, and we can just copy this instead of keep on typing. Just save some time. Of course, this one you probably can use a switch, okay? Can use switch. So I was just trying to do if else, because in the first case we have like 10 cases, okay? So A, B, and then let's do 12. 12 will map to C. And then 13 will map to D. 14 map to E. And then let's do one more, which is F. Else if 15, then that will be F. Do that. And what about other cases? If number is not in that range, else we actually have to we have to just say throw new exception. But yeah, throw new. Oh, what happened? What did I do? Okay, so we can get it back here. Throw new exception. So just say this is unknown hex digit. Okay. Else. And then finally return result. So actually just, instead of say result equal to that, just a return probably will be easier. Just say return A, return B, return C, and then in this case, throw new exceptions. Okay. Anyway, so this will map all the remainders into some kind of characters, A, B, C, D, or 1, 2, 0, 1, 2, 3. Those will be characters too. And then after that, we can just create a conversion. Let's say to hex, okay, to hexadecimal number, and also give an integer n. And the process will be very similar. So every time we need to get the integer divided by 16 and then get a remainder. So we will declare result first, string result. start with empty result, and then integer remainder. Okay, remainder. Okay, so that when you divide by 16, you get a remainder, and then you get a quotient. And let's use quotient equal to n initialize, and then we're going to use a while loop again. So while is quotient is bigger or equal to 16, then we're going to divide by 16. So get remainder. So remainder will be equal to the quotient percentage sign 16. Okay. And then we are going to add the remainder to the left of the result. However, this remainder has to be mapped to the corresponding characters. You map for hex. Okay. So we are going to say result. We can call the function first. Okay, just trying to be simple. So to call the function every time, we need to get like a character, right? So we will declare a variable before the loop. Okay, so let's say that is a string, and then that is char mapped. Okay, char mapped, and then here we'll do char mapped. So we already have the remainder, so we just need to convert the remainder number into the char. So we'll say char, call the function char mapped is equal to map for hex, and then put a remainder here to convert to characters. And then we add the char mapped into the result. So result equals to char mapped plus result. So remember always add the left, right? And then we do octal division. So we divide by 16. Quotient divided by 16. So then this will go back to the loop to check, see whether the quotient is still bigger than 16. If it is, and then you divide by 16 again, and then you get a number between 0 to 15, right? And then you put those numbers, map those numbers into ABCDs, okay? And then this process will continue. And then finally, you get a quotient, and the quotient is going to be between 0 to 15. And then you need to map again, right? Char mapped equals to what is the name of function? A map for hex. Okay, and then you do quotient because the quotient is the last one. The last one that is between 0 to 15. So if you divide by divided by 16, then you get the whatever the quotient it is itself. And you really don't need to do it again. Okay, and then just get added result, add that final char mapped to the result. Okay, and then return the result. There we go. There we go. So basically, it's kind of similar to previous process, except that for each remainder, you have to map into ABCDs, Fs, because you may have a remainder which is 10 or 11, right? So in those cases, you have to map to A, B, C, D, E, and F. All right. So finally, we can call the function and have a fitting what hexadecimal number looks like. Okay. So let me go to forms again, and then let's just create another button here. Create another button, just say hex. Okay. So let's say that ETN hex. And then this is hexadecimal number. Okay. All right, now let's double click And again, we are going to call this function. The function is to hexadecimal number. So you need the integer input and you need the string as output. So integer n will be coming from the first box, txt a dot, txt a dot text. Okay, and then you need to convert to integer. To integer 42. Okay, so that is input. And now you need to declare a variable for output, which is a string. So that would be hex number, hex number, or just say hex, okay? And then we will call the function hex equals to hexadecimal, like that. And then result, the input is n. So after we have a hex number, then we can just display the result using b box, and that would be equal to hex. Okay. So very simple process. Now let's run it and see what the hex number looks like. Okay. Okay. So let's just say we suppose we have a number like that. Hex number. Something wrong here. The number too large. Let me see. Maybe. So the integer has to have a limit. So let me just try to do a smaller number then. Okay. AA21. Okay. 256. 100. Okay, let's see. 1, 2, 3, 4, 5, 6. Okay, 1E201. Okay. So anyway, this hex number is a very important number in data networks. You probably have experienced that. So if you look at your computer's MAC address, it's all coded as hex numbers. Okay, so it's just all basically 6 of these numbers, F, A, B, those kind of numbers. All right, so this is how we get hex numbers from decimals. All right, so that is so basically in the programming class we're trying to cover some other related subjects: data networks, data analytics, economics, finance, accounting. So if I found any application that I think is good for programming, I will try to introduce it. So hopefully this is interesting to you, and let me say whether you have any questions. We have 5 more minutes. Do you have any questions about your homework? Okay, trying to finish homework quickly. Okay, don't be. If I were you, I would try to finish it by tonight or by tomorrow. Okay, so if some students need to finish it, database exam by tonight, so maybe tomorrow, finish that, and then spend the whole weekend to review for the subject. Okay, and then we're going to have a review session on Monday, and then Wednesday we'll do the exam. By today, tomorrow, maybe I'll try to do that by tomorrow, and I'll try to come up with like a short review list for you to go over it. All right. Now, let me say whether you have any questions.